Hello, everyone. All right, so for 5B, we're going to be talking about solving systems of equations by substitution. So in 5A, we talked about graphing. So we're going to kind of do a quick refresh on graphing real quick. So looking at the system here, we have y equals negative 2x minus 8, and we have 2x minus 4y equals 12. So our first equation up here, we actually have in slope-intercept form. So we can go ahead and just identify the slope and the y-intercept. So our slope here is in front of our x value, so we have a slope of negative 2. And our b value is what we are adding or subtracting at the very end. So our b value, our y-intercept, is negative 8. All right, now since our next equation here is in standard form, I'm actually going to do the standard form trick to find its attributes. So the standard form trick means I'm going to do the opposite of my a value over my b value for my slope. To find the x-intercept, that's going to be my c value over my a value. And to find the y-intercept, that's going to be my c value over my b value. So looking at your equation here, your a value is with your x, so our a value is 2. Our b value is with our y value, but since we're subtracting, our b value is a negative 4. And then our c value is over here at the very end, which is 12. All right, so I'm going to take the following values. So my slope, so I want the opposite of 2, so negative 2 over my b value, which is negative 4, simplifies to 1/2. So I have a slope of 1/2. So now for my x-intercept, I'm going to take c over a, so 12 over 2, which is equal to 6, which simplifies, or not simplifies, but correlates to 6, 0. So for the y-intercept, now I'm going to take the c value over the b value. So I'm going to have 12 over negative 4, which is negative 3, which means your coordinate is 0, negative 3. All right, so I'm going to graph my blue equation. So I'm going to start at negative 8. And I'm going to do a slope of negative 2, so down 2 and right 1. So I can only do 1 point, so that means I need to go the other way. So I'm going to go up 2 and left 1. So remember, with graphing, what we're looking for are those overlapping points. We want to know where those two lines are going to intersect. I can do one more. Okay. Now for the equation in red, my standard form equation, I'm actually going to start with my intercepts. So I can do 0, negative 3. So I'm going to do the y-intercept and the slope. So 0, negative 3. And I have a slope of 1/2, which means I'm going to go up 1 and right 1. All right, now if I go the other way, I'm going to go down 1 and left 1, which means we're having an overlapping point here, which means that's what I'm looking for. That's my solution. All right, so now I'm going to draw the lines. All right, so this intersecting point right here, that coordinate, which is negative 2, negative 4, that is our solution. So there is a way that you can check the validity of the solution. So what you can do is you can take your solution coordinate, so negative 2, negative 4, and we're actually going to plug it in to our system and check it algebraically. So I'm going to start with y equals negative 2x minus 8. All right, so now I'm going to plug in negative 2, negative 4 for those corresponding values. So negative 4 equals negative 2, parentheses, negative 2 minus 8. So what I just plugged in were those x and y values for that coordinate. So the y value I subbed in was negative 4, and the x value I just subbed in is negative 2. So now I want to simplify and actually see if that equates to a true statement. So I have -4 equals -2 times -2 gives you a +4. So +4 minus 8 gives you -4. So it works. So it works for the first one. So now we got to check the second one. So 2x minus 4y equals 12. All right, so same idea here. I'm going to plug in the coordinate. So 2 parentheses, -2 minus 4 parentheses, -4 equals 12. So 2 times -2 gives you -4. Then -4 and -4, when you multiply, give you +16. So when you do -4 plus 16, you get +12. So the solution works for both of them, which means it is a valid solution for the system. So just to note, the the solution here, has to work for both. If it only works for one and it doesn't work for the other, it's not a solution. The solution must work for both equations or all the equations that you have in the system. All right. So now moving on to substitution. So we're going to do one of these kind of step by step. So substitution, in reality, think of it like if a teacher is out, you have a substitute in its place. So you're taking one value and you're putting it in for another value. So a sub would be in my place when I'm not here. So it's kind of the same idea. So we're going to solve one of the equations for one of the given variables. So meaning we want like an x equals equation or a y equals equation. So kind of like how we have up here, we want one of these equations, one or both of these equations to be an x or a y equals equation. So then we're going to use that new equation and plug it into the other equation for that variable. All right. So we're going to start at step 1. So we are given the system here. It's literally the same one that we just did. So step 1's actually done for us because we already have a y equals equation. There will be times where you actually have to manipulate the equation and you have to solve for a variable yourself, but in this case, it's already done. So in this case, we have y equals -2x minus 8, which was already done. So then we have 2x minus 4y equals 12. All right, so I'm going to actually go on to step 2 since step 1 was done for us. So step 2 is when I'm going to take that equation that is already solved, meaning I already have a y equals equation here. So what I'm going to do is I want to take that equation and I want to throw all this in here for y. So what I'm doing is y is the same as -2x minus 8. So I'm going to sub all that in for y. So I'm going to have 2x minus 4 parentheses, and I'm subbing in that y value, which is -2x minus 8. And that's going to equal 12. So all I'm doing is replacing that variable with the other expression, or the other equation. So now notice, once I subbed in, that y value is no longer here. The only variable I have now is x. So what I'm going to do next, I'm going to take this equation for step 3, and now I want to solve for x. So to solve for x, what we're going to do is we have to distribute. So when I distribute, so 2x plus 8x plus 32 equals 12. Now we will just want to keep simplifying. So I'm going to combine 2x and 8x. So that's going to give me 10x plus 32 equals 12. So the next step, I'm going to subtract 32. So this is just like any traditional equation that we would solve in like unit 1, for example. So 10x equals -20. Then I want to divide by 10. That's not a 10. There we go. So x equals -2. So I just solved for x. Now keep in mind your solution is going to be a coordinate, an x and a y value. So we found the x value, but now we need to find the y value. So what I'm going to do, I'm actually going to use this x value that I just found to find my y value. So look back at your equation in step 2. We have a y equals equation right here. So what I'm going to do is use that equation to my advantage. I just solved for x, so now I'm going to plug in, that's not a, there we go. So I'm going to plug in for my x value so I can find my y value. So -2 parentheses, then my x value from step 3 over here is -2. So I'm going to plug in -2, and -8. So I'm going to have y equals +4 minus 8. And then when I simplify, you get -4. So it's the exact same answer that we got up when we did graphing. We're just doing it a different way. So our answer here is still written as a coordinate. So it's still -2, -4. All right. So that's if we lay it out step by step, but you don't have to do it step by step like that. So we're going to try a few practice problems. All right, so looking over, we're going to start with number 2 since it's already set up. So with number 2, we already have a y equals equation. So I'm going to take that y equals value right here, and I'm going to sub that in. Let's not do that. I'm going to sub all this in right here for my y value in my other equation. So I'm going to start with 9x plus 2 parentheses 3x plus 1 equals 17. So this 3x plus 1 right here, this is what I'm subbing in. This is from the other equation. All right, so now I want to solve for x. So I'm going to distribute. So I have 9x plus 6x plus 2 equals 17. All right, so once again, just as before, like unit 1, solving equations. So you got to combine like terms and do your inverse operations. So 9x and 6x combine to give you 15x. So I have 15x plus 2 equals 17. So now I'm going to subtract 2 on both sides. So 15x equals 15. Now you want to divide both sides by 15. So 15 divided by 15 gives you 1. All right, so I found the x value. Now I still got to find the y value. So I'm going to use my equation up here that's already solved for y. Now here's the thing. You can actually still plug it into your second equation that's already in standard form. If you want to plug it into that equation, go for it. It doesn't matter. I just recommend using the equation that's already solved for y. That way you're not actually creating more steps for yourself. But if you want to use standard form, you go for it. So I'm going to use the top equation. So y equals 3x plus 1. So plug in my x value. So y equals 3 parentheses 1 plus 1. So 3 times 1 gives you 3 plus 1, which means your y value is 4. So our coordinate here is 1, 4. All right, so now let's jump back over to number 1. So now if you look here, your equation is not necessarily set up for you already. So this is where you actually have to manipulate an equation. But if you notice, look at all of your values that have a variable. We want to look for a value that has a coefficient of 1 or -1, ideally. So if you notice, this coefficient right here, this y down here, has a coefficient of 1, which means that's going to be the easiest equation to solve for. So that's the indicator to me that I'm going to take that equation, so 4x plus y equals 24. I want to solve that equation for y. So to solve it for y, I'm going to subtract 4x. So I'm going to have y equals -4x plus 24. If you want to do 24 minus 4x, it's the same thing. I'm just writing it in slope-intercept form just for the sake of writing it in slope-intercept form. All right, so now I have a y equals equation. Now keep in mind, we manipulated the bottom equation. So because we manipulated the bottom equation, that means I actually have to take this entire y equals equation and plug it into the top equation. Because if you plug in the bottom equation to the bottom equation, you're going to contradict yourself and it's not going to go anywhere. You have to make sure you're plugging it into the other equation. All right, so I'm going to take my equation, so 2x minus 3y equals -2. So now I want to plug in for my y value. All right, so I'm going to have 2x minus 3 parentheses -4x plus 24. And that equals -2. So now here, we want to solve for x. So I'm going to distribute. So I'm going to have 2x plus 12x, then minus 72. Yes. Math is hard. Okay. Wow, that is terrible. There we go. All right. Now, once again, now we're going to solve. So I'm going to combine 2x and 12x, which gives me 14x. Nope. Minus 72 equals -2. All right. Next step, so I'm going to add 72. That is terrible. There we go. So 14x equals 70. Now I want to divide by 14. So x is equal to 5. All right, so now I solved for my x value. Now I still got to solve for my y value. So here's your kind of next step. You have options. You can plug it into your top equation, your bottom equation, or you can plug it into a manipulated equation over here. Because I already have a y equals equation, so I'm actually going to go ahead and just plug it into that equation. So I'm going to jump over here. So y equals -4 parentheses 5 plus 24. So I'm plugging in for my x value that I solved for already. So y equals -20 plus 24, which means my y value is +4. So my solution here is going to be 5, 4. Okay. So moving on. So number 3. All right, so these problems are going to look a lot more confusing than they actually are. But one thing I want to kind of point out, and it's going to seem kind of weird, but just kind of bear with me. So think of it this way. 2 equals 2, reflexive property. 5 equals 5. 6 equals 6. Now, the same idea is also going to go for variables. X equals X. Y equals Y. They're the same thing. So what I'm going to do is see how both of these equations have a Y value. So I'm actually going to take this reflexive property here, and I want to set them equal to each other, because I know Y is the same as Y. 4 is the same as 4. 5 is the same as 5. So it doesn't matter which one you put on which side. So let's say I put this X on this side, not X, that Y, and this Y on this side. So my equation is going to look like 2 minus X equals 3X minus 6. So now we have an equation that we can solve. So I'm going to add X on both sides. So we're going to have 2 equals 4x minus 6. Now I'm going to add 6. So I'm going to have 8 equals 4x. Now divide by 4. So you're going to have x equals 2. So now that I have my x value, now I need to solve for my y value. So just as mentioned before, it literally doesn't matter which equation you use. You can plug it into either one. So just for the sake of keeping it as easy as possible, I'm going to use the top equation. So just y equals 2 minus x. So I'm going to plug in my x value for x. So I'm going to have y equals 2 minus 2, which, math is hard, 0. All right, so your coordinate here is going to be 2, 0. All right. So looking at this next one, I will say this one's kind of tricky. However, despite it being a little bit tricky, step 1 is already done for us. We already have a y equals equation. So what I'm going to do, so x minus y equals negative 10. So I'm going to sub in for my y value. So x minus, parentheses, 3x minus 5 over 10 equals negative 10. Okay, you have options in how you'd like to handle this. Personally, I would say simplify the inside as much as possible, get it to separate terms, that way it makes the distribution easier. That's just me. If you have another way that you prefer to solve it, you go for it. So what I'm going to do, so x minus, I'm going to separate it. So 3 over 10, x minus 5 over 10 equals negative 10. Now I'm going to simplify. So x minus 3 over 10x minus 1/2 equals negative 10. Now I'm going to distribute this negative here. So when I distribute that negative, so x minus 3/10 x plus 1/2 equals negative 10. All right, so let's try options. Okay, one thing I think that will benefit everyone is notice how you have a fraction like this in the denominator, times 10. So I'm going to multiply everything by 10 just to get rid of the fractions, get them gone. Just multiply everything by 10. It will make the numbers bigger, but I will say I'm pretty sure a majority of you would prefer bigger numbers as opposed to fractions. So 10x minus 3x plus 5 equals negative 100. All right, so now based on this, I'm totally improvising. I actually did not do it this time. So I'm going to combine my terms. So 7x plus 5 equals negative 100. So now I'm going to subtract 5. So 7x equals negative 105. And now you want to divide. Hello, there we go. So we're going to get next value of negative 15. All right. So another option that you could have done, you could have just stuck with the fractions, get common denominators, whatever you can. But for the sake of just getting rid of the fractions and dealing with whole numbers, I feel like this might be the best option for a lot of you. All right, so we found the x value. Now I need to find the y value. So I'm going to use this equation here that's already set up. So y equals 3 times negative 15 minus 5 over 10 All right, so that's going to equal negative 45 minus 5 over 10, which is going to equal negative 50 over 10, which simplifies to negative 5. All right, so your coordinate here is going to be, where did my 5 go down here? There we go. Negative 15, comma, negative 5. Well, that one was a lot. I'm tired of that one. Okay. If anything, this is the hard one. So if you can make it through that one, you can make it through any of these. All right, next. So number 5. All right, so notice how we have our systems, or our equations here are in standard form. So I need to solve one of these equations for slope-intercept form, or an x or a y equals equation. So I've been solving for y this whole time. So I'm actually going to take the top equation. I'm going to solve for x this time. So to solve for x, I'm going to subtract y. So I'm going to have x equals 3 minus y. So I'll leave it backwards this time, just show you it doesn't matter. All right, so now that I have an x equals equation here, I'm going to plug it in for my x value in my other equation. So I'm going to have negative 4 parentheses 3 minus y minus 4y equals 12. So I'm going to have negative 12 plus 4y minus 4y equals 12. So one thing I want you to notice here, positive 4y, negative 4y, they zero out. That's a zero pair. So what we have left is negative 12 equals positive 12. Well, last time I checked, those are not the same thing. So because you get a false statement, that means this is actually going to be no solution. So on a graph, perfect. So on a graph, these lines would be parallel. They just do not intersect. All right. So for number 6, can I count? Yes, number 6. All right, so same idea. I'm going to take my y value, plug it in for y down here. So 9x minus 3 parentheses, 3x plus 1 equals negative 3. So now I'm going to distribute. So 9x minus 9x minus 3 equals negative 3. So if you notice, something similar is going to happen. Those 9x's, they zero out. Notice how we don't have any variables left. We just have negative 3 equals negative 3. So what that translates to is, because it's a true statement, instead of no solution, it's going to be all of them. So it's going to be infinitely many solutions, or IMS, which means these two lines are going to be overlapping on a graph.